Okay, section 3.8, rates, ratios, and percents. And the thing that all three of these have in common, should probably be a fourth word up here, proportions. We're going to solve most of our problems tonight using proportions. And I know that you guys worked with proportions in your 7th and 8th grade middle school math courses, so you'll be able to apply that knowledge today. And then if not, you can kind of learn as we go along. Nothing here is going to be really hard, but you do need to pay attention. You can get confused from time to time, sometimes with what goes in the numerator and what goes in the denominator. Okay, so it says if A and B are two related quantities measured in different units, then the rate of A per B is A over B. And the part here I want to stress is the use of the word per. Like when we say miles per gallon or miles per hour or meters per second, okay? We can express that mathematically with a fraction. And whatever we mention first goes on top in the numerator. That would be the A part. Whatever we say last, the B, would go in the denominator. So when we say miles per gallon, we're actually saying miles over gallons or miles divided by gallons. Same with miles per hour. It's miles divided by hour or miles over hours. Okay? So we're just taking something that we talk about a lot in everyday speech, but we're going to be writing it mathematically. Our focus tonight is going to be unit rates. Okay? A unit rate is a rate per one given unit, such as 60 miles per 1 gallon. You know, if you go to buy a car and you're interested in the gas mileage, you know, the salesman's probably not going to tell you, oh yeah, this car is great, it gets 120 miles for every 2 gallons. Well, that's kind of confusing because you almost have to do some math there to calculate, well, I don't care how many it gets in 2 gallons. My brain kind of wants to know how many does it get in 1 gallon. So with a unit rate, we'll always have a denominator of 1 unit because it allows us to compare things a lot more easily. Okay, so go ahead and get out that pencil and paper. We're going to go through a couple of examples of this, and you have a lot of examples to do on your own, but I want you to go through this with me. It says find the average rate per hour, so per 1 hour, if you travel 456 miles in 3 hours. And what we want to do here is we're going to utilize proportions. There are many ways of going about this problem, and we don't all necessarily need to do it the same way, but the way I'm going to be consistent with is using proportions because it's going to help you on later on in the year. So what we have here is 456 miles, and it said miles per 3 hours, so that would be over 3 hours. This is how you would write this mathematically. Now that's not a unit rate. A unit rate is going to tell me how many miles for every 1 hour. And here's where we can set up a proportion. Okay, so we're going to have a similar relationship, but instead of for every 3 hours, we want to know for every 1 hour. So how many miles would that be? That's going to be our x. Okay, and so hopefully you remember how to solve these things. When you have a proportion, if you want, a quick trick is to look at the two corners that you already know, and those guys you can multiply. You might have heard of cross multiplication. It's kind of what we're talking about here. So 456 miles times 1, it's just going to give you 456. Whatever you get there, you can divide by the third number you know, and that will always lead you to your answer. Okay, so go ahead and type that in your calculator right now. 456 times 1, enter, then divided by 3, enter. And let's see if we get something reasonable here. What we come up with is 152 miles per every 1 hour. And this is the unit rate because we have a denominator with 1 given unit. And you are completely fine writing it like this. Now another possibility, and this would also be okay, is to write 152 and then you'll just see the units in a fraction. Miles per hour. And we know that that hour is singular, so it's another way of saying 1 hour. You could also write it that way. Okay, so those are unit rates. Come back to that. Okay, this will be another way to practice setting up proportions. So let me read this along with you. It says you tested a sample of 40 footballs from a shipment of 1,750 footballs to be used in the football season. Of the 40 sampled, you found that 6 balls were under pressure for gameplay, so they were underinflated. Okay? Using this sample, estimate the number of balls that will be under pressure from the whole entire shipment. Okay? So what I want you to do right now is take this information and I want you to set up a proportion that represents the problem. And to give you a little bit of hint, you know, all proportions follow this one basic anatomy. It's going to be some part compared to some whole that will be set equal to another part compared to another whole. And so your job is just to kind of locate what would be considered a part and what would be considered a whole and which numbers really go together. Okay, so go ahead and attempt to set up a proportion. Hit pause now, and then we'll see if ours match up. Okay, so here's the one I came up with. And it might not be the same as yours. There are a lot of right answers here. Okay, but for me, I went with the sample first. So I saw that 40 balls were sampled and 6 of them were under pressure, underinflated. So to me, that's a part out of a whole. Out of the 40 sampled, 6 of them were underinflated, a part out of a whole, 6 out of 40. Okay. Now, for my proportion, I'm going to have to use that 1750 number. Do you think that that's a part, or do you think that that's a whole? Well, it is the whole shipment. So I want to know out of the whole shipment, out of the 1750, how many are underinflated. So that is one possibility. You could also have these two fractions on different sides, and that would also work. You could also have tops and bottoms flipped. You can have whole over part equals whole over part, and that would also work. And then a few of you might even have something like 6 over x equals 40 over 1750, sort of a horizontal relationship, and that would be totally fine as well. Okay, so just make sure that your proportion matches up to something like mine. Go ahead and get out your calculator and then go ahead and solve this thing. This is a lot like the last one. We can take the corners we know. So you're going to multiply those, 6 times 1750, enter. And then you'll divide by 40. Divide your answer by 40, enter. And it should go ahead and give you the x. So go ahead and type that in, see what you get. And you should get a decimal. I believe it's 262.5. So we're going to use our approximation symbol here. X is approximately equal to, we'll round up, 263 footballs under pressure. Notice that this is not a unit rate problem because our denominators are variable. One of them is 40 and one of them is 1750. So you'll have to distinguish problems that are just simple comparisons that involve proportions and problems that involve unit rates. Okay, that's basically the lesson. Now we're going to do a lot of practice because this is something you learn by doing. All right, so I'm going to give you 7 or 8 of these guys. Let's start with some unit rates. It says you can buy 8 cans of soup for $5.64. What is the unit rate? And notice they don't give you too much information here. You're going to have to make a decision. Okay? Do you think we want to know cans per $1 or dollars per 1 can? You have to use common sense here to kind of figure out what unit rate makes the most sense. When you go into a store, right, are you going to be looking for how many cans you can get with a $1 bill, or how much money it's going to take to get 1 can? So that's for you to decide. Go ahead and set up your proportion and let's see what you come up with. Okay, so go ahead and do this one on your own. Hit pause now, and then we'll reconvene to go over answers. Okay, well hopefully you came up with a proportion where you want cans per, no I'm sorry, where you want dollars per cans. Okay, so cans should be on the bottom because what we're really after here is how much it's going to cost for one can. So you could set this up with $5.64 per 8 cans. That is really your rate, okay? Your unit rate is just going to be an equivalent fraction, but instead of 8 cans, it's going to be over 1 can. So that's what you're out for. You're out for how much it's going to cost over 1 can. So you can solve this by cross multiplying here. 564 times 1 gives you 564, and then your calculator can hit divided by 8, and that should bring you to your answer. I believe it's going to spit out something like 0.705, and since we're dealing with money here, we can round to the nearest cent. So answer can look something like this. X is approximately 71 cents, or I'm going to express my answer in dollars. So $0.71, okay, per can. And that would be fine, having the can in your denominator per 1 can. So we want to see something that looks like this. Okay, hopefully you got that one right. Good job. Let's go ahead and try another unit rate problem. So you drive 700 miles in 13 hours. What is your average speed? And when we find average speed, it's going to be in the form miles per hour. So that's another example of finding a unit rate. Okay, go ahead and do this one on your own, and then we'll reconvene to go over answers. Okay, let's go ahead and set this guy up. You can kind of check your proportion against mine. I went with 700 miles over 13 hours equals how many miles over 1 hour? And basic unit rate problem. So I take out my calculator, I cross multiply here. 700 times 1 is 700, enter, and then divide by 13, enter. And let's see, what do we come up with when we do that? I think you get a decimal, maybe something like 53.846. So I rounded that to the nearest mile per hour. So I got 54 miles per 1 hour. And that would be your unit rate, and that's definitely a reasonable answer. Okay, so hopefully you got those two. Now let's move on to another type of proportion. Let's get into percentages a little bit, and we haven't talked about percentages yet. But you can see down at the bottom, whenever you're working with percentages, it's often possible for you to use this special proportion, where it's going to be a part out of a whole equals whatever the percentage is out of 100, because a percent is basically a fraction out of 100. Okay, so some part to some whole will equal some number compared to 100, and that number will be your percentage. So let's take a look at this one together. It says you're on a date and you tip $11 for a meal that costs $53.87. What percentage is your tip? Okay, I want to go through this one together. So let's set this up together. You know we're going to use a proportion. So it's going to be some part out of some whole, and that's going to equal some percent number over 100. And in this problem, we don't know the percentage because that's what we're asking. Even up in the question, it says what percentage. So we don't know the percent number. That's going to be our x. So let's focus on the part and the whole. Okay, so what is the part, what is the whole? Well, it says you tip $11 for a meal that's $53.87. So, we're trying to come up with, $11 is how much of that $53.87. What percent of that $53.87 is it? So $11 is definitely your part. And $53.87 is definitely your whole. Okay, so if we can figure out what X is here, we will know the percentage. So I want you to go ahead and do this. Go ahead and solve this as a proportion and see what you come up with for X and see if it, if it roughly makes sense. And you can go ahead and round to the nearest percent. So you don't have to go out to tenths or hundredths. Round it to the nearest percent. If you need to hit pause, go ahead and do so now. Okay, well, you're going to multiply 11 times 100 in your calculator. You get 1100. So you multiply the two you know, and you divide by your third number. And that's something I definitely can't do mentally. 1100 divided by 53.87, and whatever you get, that should be your percent number. Now, when I type that into my calculator, I got 20.419, something like that. So I'm going to round that to 20%. Is that a reasonable tip amount here? Yeah, I would say so. $11, 20% of $53 is pretty close. Okay, so that's basically how we'd go about doing a percentage problem. Okay, let's try one on your own. Now this one's a little bit more complex, so make sure you read it carefully. It says you want to leave a 21% tip on a bill of $64.75. How much should you leave total for the bill and tip? So I want you to take some time with this one. Definitely hit pause. Go ahead and reason this one out. You want to use some proportions along the way, and then we'll come back and see if our answers match up. Go ahead and hit pause now. All right, let's see how we did. This is kind of a two-part problem, so hopefully you kind of went through both parts here. Okay, so a part out of a whole equals some percent out of 100. And my proportion here was X out of 64.75 equals 21 out of 100. And the reason I went that route is because we already know what the percentage is. It says we want to leave a 21% tip. So this number, the percent number, is already dialed in for us. What we don't know is what portion of the 64.75 would be the 21%. So I'm looking for the part out of the 64.75. Okay. Now these are the two numbers that you know, 21 and 64.75. So those are the numbers that you should cross multiply first, and then you divide that answer by 100. Okay. And when you do that, I believe it gives you something like 13.5975. I think that's right. Okay, that's not your final answer. And since that's not your final answer, you really don't want to round that yet. Okay, remember we're going to put off all rounding to the end. So when you get something like that in your calculator, please leave it in your calculator. Go back to the question. Remember, the question says, how much should you leave total for bill and tip? So this part represents the tip, but we also have to leave the amount of the bill as well as the tip on top of it, right? So you're going to take this and you're going to add it to the 64.75. That's what you want to go ahead and do in your calculator. Okay, and I believe when you do this, you're going to get something like 78.3475, and this is the number that you are allowed to round. So since it's money, we can round it to the nearest penny. We're looking at the 4, and we're going to focus on the 7. The 7 is going to make the 4 go up to a 5. So we're talking about $78.35, okay, for bill and tip total. So hopefully you got that. If you came up with 1360, don't feel bad. That's definitely part of the way to getting to the answer. But just make sure you always go back to the question and see what they're asking. Sometimes the proportion is just a means of getting to the final answer. All right, good job on that. I think we have 2 more here. All right, proportion problem. 336 out of 1185 students at Brophy are freshmen. What percent is that? So go ahead and use your knowledge of proportions. Go ahead and figure that one out. Good luck. Okay, so we're using that part out of a whole, excuse me, equals percent out of 100. And hopefully you see the part as the 336 out of 1,185 equals how many out of 100? And that x would be the percent number. Okay, so cross multiply here, get your answer and divide, and you should have come up with 28.35. And we could round that, let's say, to the nearest percent. So x is approximately 28%. So 28% of all Brophy students are freshmen. Okay, hopefully you came up with that guy. 336 times 100, enter, divided by 1185 should give you 28%, or 28.35. All right, last one. You leave $8.31 tip on a $42 meal. What percentage is your tip? So if you've been paying attention, this should be pretty basic. Okay, go ahead and hit pause now. Try this one on your own. And let's round your answer to the nearest tenth of a percent. Okay, so whatever you get for your answer, let's go ahead and round it to the nearest tenth of a percent. Okay, we've got part out of a whole, so $8.31 is the part, and $42 is the whole. And basically I'm just looking for what percentage that is, so it's some number out of 100. Okay, and here's where your calculator really comes in handy. So these are the 2 numbers I know. You can type in 8.31 times 100, enter, and then divided by 42, or 42.00, enter, and that should kick out your answer. And I came up with 19.785, something like that. I asked you to round to the nearest tenth of a percent. Okay, so this is the tenths place right here, and we're looking at the 8, and the 8 is going to cause the 7 to rise up 1. So answer x is approximately equal to 19.8%. Okay, very good. So that's rates, ratios, and percents, and notice that we utilize proportions to work on all of these. It's going to help you in the second semester, your ability to set up proportions, so that's why I wanted to introduce it this way today. Good job with that, and good luck on the assignment.